Now, extensive and intensive property, these are just definition and very simple questions are asked. So if you remember the extensive, and I will tell you the way also how you can remember which one is intensive property, which one is extensive property. So first try to understand what it is. So suppose you have this container and it has a gas, the volume is V, temperature is T. Now if you place a partition, okay, you divide it into two equal halves. You see that volume is changing. Volume, new volume is half, but temperature is same. Temperature will not change. This gives us an idea about that all the properties are not similar. Okay, they are different. They are different in the sense that if we change the size, okay, if we change the size, their behavior or their value changes. So in this case, the one which changes means volume is known as extensive property. So the parameters, okay, which change with size or amount are known as extensive parameters, and they represent extensive property. Okay, so extensive property shown by extensive parameter. The one which remains same, intensive. Okay, so extensive property, property whose value depends on quantity or size, that is amount or size of matter present in the system. Extensive. So for example, mass. So if you divide one piece into two, the mass will change, volume will change, their internal energy will also change because it is now half the mass, there will be half the energy. Enthalpy will change. So if you have this much amount and it has been heated up to some temperature and it has Q amount of heat, if you divide it into two, this one will have Q by 2 and Q by 2 heat. Okay, enthalpy will change. Heat capacity, this is something I will be talking about later on. What is heat capacity? That will also change. Heat capacity is something that how much, how easily it can be heated. Okay, that is heat capacity, or how difficult it is to heat a particular matter. All these are extensive property. Why? Because if you change the size, the property will change. Intensive property, opposite. So if they do not change with size, these are intensive properties. So for example, you have seen temperature did not change, same density will not change. So if I show you the same example here, whatever is the density of air here, the same density of air will be here. So suppose you have two rooms, okay, you have one room and you divide it into two parts, it will not change the air density in that room. Okay, so in your house, if you have 4 rooms, 5 rooms, every room will have same density. It will not depend on how big it is or how small it is. Okay. So density will remain same. Similarly, temperature will remain same. Also, pressure will not change. Okay, pressure will be 1 atm everywhere. It will remain 1 atm. So pressure also is intensive property. Temperature, density, pressure, these are intensive properties. Now, how do you remember, right? So it is easy to remember that pressure will not change around you, whether you are in very small room, whether you are in big room, or whether you are outside of your house. Pressure is same. Okay, you are experiencing 1 atmospheric pressure only. So it means pressure does not change. So it is intensive property. How you can remember it is intensive property? You will remember the keyword pin. Pin. Okay. You can remember this keyword. As I said, you need to remember the word Hert to remember the formula delta H equals to delta U plus delta NGRT. Similarly, remember this keyword pin. It means pressure is intensive property. And you know that pressure does not change. Okay, it is very well known fact that pressure in your room, in your house, outside, everywhere it is same. It means if any parameter is constant, it is intensive property. Opposite is for extensive property.